All right, we're looking at A23, their notes on solving quadratic equations by using square roots. So this is something a little bit different. And if I ask you for the square root of 25, you would all tell me it's what? 5. You would tell me it's 5. And then you see this other blank here. And I don't know if you can remember way back to the beginning, we talked about how it could also be negative 5. So when we're breaking roots down, we were just looking at the positive principal value.
I'm a big calculus guy.
All right, so the idea is when I'm asking you what the square root of 25 is, most of us would say 5. But here's what we're talking about today. If I say x squared equals 25, I'm really asking you what you can square and get 25 with. Well, 5 squared is 25. That is just 5 times 5, which is 25. But negative 5 squared is also 25 because it's a negative times a negative. Now, I've been really pushy when you guys use your calculators about putting your x's in parentheses, and that's why. If I type this in my calculator, it is going to be negative and then 5 times 5, which is negative 25. We're not doing that. We are taking a number times itself. So if it's negative 5, it's negative 5 times negative 5. So when I ask for the square root of 36, most of you could say 6. But what else could I square and get out 36 with? Negative 6. What's the square root of 81? 9 and negative 9. So what I need you to put on the top of your paper is a big plus minus sign. That is your reminder. Maybe you put it on your note card. When you're solving a quadratic, you're going to get two answers. It could be a positive or it could be a negative. All right, so every square root has a positive and a negative answer. Okay, every square root will have a positive and negative answer. All right, you cannot take the square root of a negative real number. So we can square a negative number, but we cannot take the square root of a negative number in the real system. The square root of a negative produces an imaginary number. Now, we are not going to get into imaginary numbers. That's more of an Algebra 2 concept. But that is something that exists, so we can deal with the square root of a negative. Okay, so the reason we practice our equation solving is because now we're going to mix equation solving with roots. Okay, so looking at this, examples of equations by solving square roots. If this was just x equals, we'd be done, but it's x squared. Now, think about your order of operations. Please excuse my dear Aunt Sally. We are going to work our order of operations backwards. We want to check for anything we can do. If I'm working these backwards, there's no addition, subtraction, there's no multiplication, division. And the next thing would be exponents, but exponents are also clumped with roots. So I do have an exponent. I have power of 2. What's the inverse of a power of 2? The root. So if it's a x squared, then I would take the square root. And if I do it to one side, I do it to the other side. So a square and square root cancel, and I get x equals, well, what is the square root of 16? You would tell me 4, but what else? Positive or negative 4. And you can write it this way. You can stack so we understand it's positive or negative 4, or you could just write 4 and negative 4. I'm pretty lazy, so that's the answer I go with. Okay, this is what I need you guys to think about. Just come down here. I'm going to do a little scribble work. If I gave you the square root of 5 squared, we type that in our calculators. Let's type that in our calculators exactly as it is. Square root, make sure you're using your square root key, of 5, close the parentheses or don't, but put the power on it, and I get 5. If I type it in this way with the 5 and I put the power on the inside, I still get 5 because these things cancel and I get 5. They're inverses. This was really the square root of 25, and the square root of 25 is simply 5. So a square and square root are inverses. Now, if I want to check that, 4 squared, and again, I'm going to be picky, put your parentheses here. 4 squared is 16. Negative 4 squared is also 16. But if I choose not to listen and I don't put this in, then I get negative 16. We have to be very careful with our parentheses. Can't stress it enough. All right, next problem. X squared equals 100. We're starting off pretty easy here, and we're starting off with nice numbers. How do I get rid of the square? Square root it. Now notice the square was isolated, so I could just jump in. This cancels. I get x equals what? Say it again. Nope. Positive 10 or negative 10, right? Shouldn't I have two answers? 10 squared is 100. But isn't negative 10 squared also 100? Okay. All right, let's do this next one. I'm going to do x squared equals the square root of 24. That one's not so easy now, is it? I'm asking you what squared gives me 24. So I'm going to take the square root. That's going to cancel. But 24 is not on my perfect square list. So this is why I was asking you to have your perfect square list out. This is where we go back to, can I break 24 down with the perfect square? What's the biggest perfect square that goes in 24? Well, half of 24 is 12, so it's got to be either 9 or 4, and it's what? 4. So again, I'd like you to write it with the perfect square first and then the number after it. So what's the square root of 4? Nope. Positive or negative 2 square root of 6. I know you guys are like, yes, it is. The square root of 4 is 2. But when I'm asking the square root of 4, it's coming from what squared could give me that. Now, this looks like a weird answer. But if you type in the calculator 2 square roots of 6, this is the approximate answer, 4.89. So x is approximately 4.89. Now, that's not repeating. Notice that it goes, so it'd be like 4.9. If I come back to the original and I type in 4.89, what was it, like 897 something squared, do you see how close I get to 24? And if I came back and I typed in the negative 0.489897 something, do you see that I also get back close to that 24? That's the idea, but we want that exact answer. All right, now there is something different about the next one. Do you see it? What's different between these two? Well, between these four. There's a plus 2. It's not isolated. So your first step is to isolate the square. So it's pretty much just like getting the term by itself. So I would get rid of any addition or subtraction first, then multiplication, division, then get to my exponents. So I'm going to subtract 2, cross the line, change the sign. So I get x squared equals 49. Well, that's a lot nicer. So what's the square root of 49? Oh, I can't get you this time, huh? So this is why I'm taking the square root. X equals positive or negative 7. Now, bless you, if you go back to the beginning and you type in 7 squared, which is 49, and you add 2, you get back your 51. If I go back up and I put in my negative 7 squared, I also get 51 because that's a positive 49. All right. So I know the problems aren't in here for you to work ahead, so that is why we are working together. So here we go. We have x squared minus 3 equals 75. Put a 75 in there. So you'd have to be given the whole problem. We're just doing it this way. All right, so what should I do first? Add 3. Okay, cross the line, change the sign. So I get, add 3. Oh, I meant to make this 72. Can we fix that? 75 is what I wanted. Sorry. Okay, 72. So I will add 3, and I get x squared equals 75. Now, you're not going to take the square root up here because you're not going to take the square root of that minus 3. So that's why we want to isolate it. Now come in and take your square root. And so I'll start, so I don't even forget, I'm going to put a plus or minus sign here. And let's think about breaking down our 75. What is the biggest perfect square that goes into 75? 25. All right, so 25 times 3. So notice my plus or minus sign I built in. The square root of 25 is 5. Keep the square root of 3. There you go. All right, let's see if I can get this problem right. Next problem is 23. There's more stuff going on. So I have a half, I have a power of 2, and I have a 3. What should I get rid of first? Okay, so what would you do to get rid of that plus 3? Okay, I agree. Subtract 3. I'm left with a half x squared still equals, but now it's 20, right? Now what? Get rid of the 1/2 or get rid of the power 2? The 1/2. Now, how do I get rid of that? You're 100%. Yeah, it's 1/2 times x. So you have two options. You could divide by a half, and I'd probably use my calculator because a lot of people mix it up and they're like, oh, it's 10. Guys, you're dividing by half. Think about it. If you have $20 and you want to know how many half dollars that would be, that's 40, isn't it? So take 20 divided by a half, and you should get 40. Now, me personally, I wouldn't divide by a half. I would have multiplied by the reciprocal. I would have just come in and said, hey, instead of dividing by a fraction, we multiply by the reciprocal. That cancels, and I get my x squared equals 40, and I don't have a chance of messing up my brain. Okay, now I still need to get rid of the square by taking the inverse, the square root. So here I go, x equals plus or minus. That way I don't have to get my paper turned back to me to fix. And let's break down our 40. What's the biggest perfect square in 40? Yeah, 4. Now, how do you know you found the biggest perfect square? There's a couple ways. Just new? Okay, one way would be to cut your number in half. That's the biggest thing that would go into it, and then you start going down the list. The other way is to look at that 10. 10 breaks down. Factors are 2 and 5, 1 and 10, but there's no perfect square factors. So final answer, plus or minus 2 square root of 10. All right, 2 more. So I'm going to let you guys start this one on your own. There's a little more to it. So 2x squared plus 5 equals 167. All right, ladies and gentlemen, what did you want to do first? Okay, I'm with you. Subtract 5. So I get 2x squared equals 162. Now what? Oh, okay, perfect. We want to isolate the x squared. Divide both sides by 2. What's x squared equal? Oh, why is that so nice? 81's a perfect square. Yeah, so I can take the square root of 81. Now, what was my answer? Oh, look at you guys. Normally I have to yell about that for like a week. And I'll tell you you're wrong when you tell me square root of 81's 9 and you look at me like I'm crazy. Perfect. Now, will you remember that tomorrow? All right, next problem. 3x squared plus 15 equals 12. Go. Mr. Arms, are you being all negative? Did you like my pun?
Yeah.
Thank you, Mr. Arms. On a Monday? That's pretty impressive. First thing Monday morning? Just 8 o'clock? Pretty impressed by myself. All right, guys, I'm subtracting that 15 first. Then I get 3x squared equals negative 3. Then what? Divide by 3. And then I get x squared equals negative 1. And then, because I have an x squared, I take a square root. Does it actually say domain error, or is it like dom-er? Oh, it actually does say it. Okay, impressive. Why is it a domain error? You can't take the square root of a negative, just like we said in the directions. Domain is your input. There is no input that you can square and get out a -1. If I square 1, I'll get out 1 times 1, which is 1. If I square -1, I get -1 times -1. And those two negatives cancel. There is nothing that you can multiply by itself to get out a negative. Because to square something and get out a -1, you have to have one negative sign and one positive. And if you're taking something times itself, they have to be the same sign. Now, the only way, so this one would be no real solution. There are solutions, they are imaginary. This is no real solution. The only way this would work is if you had like a negative outside. And you say, hey, I want to take the opposite of x squared. Take the opposite of this. That would be like this, and then we would get it. Now, these two negatives don't cancel because you have to do the power first. And so we'd have these two negatives cancel, and you'd have that leftover -1. That is the only time you're going to square something in a negative is if you do something to it after. All right, so we work.